Good morning, students. Physics chapter 2, units and measurement. And yes, today's topic is mass. What is mass and how to measure mass? See, mass is one basic property of any matter. Mass is basic property of any matter. And yes, mass does not depend on external factors. External factors means temperature, pressure and location. Okay, yes, my mass is around 57 kg. So it means if here I am inside room or I am outside room, here if I am in cold weather or hot weather, okay, if I am in AC room or if I am in room without fan or AC, then my mass remains constant, my mass remains same. Okay, it does not depend on pressure. By applying pressure there is change in size, yes, but mass remains constant. Mass remains constant. Also location. Yes, right now I am here in India, in Gujarat, in Anand. Yes or no? And my mass is 57 kg. Now on earth, if I am at any place, my mass will be same. My mass will be same. If I am moving from above, from surface of earth or below surface of earth, my mass will be same. My mass will be same. Clear about this? So yes, what is mass? So yes, mass is basic property of any matter. Okay. Mass is basic property of matter. Mass is basic property of matter. Okay. It does not depend on external factors. Like temperature, pressure and location in space. Clear about this? So yes, measurement of mass in this topic. First we have to understand what is mass. Mass is basic property of matter and it does not depend on external factors like temperature, pressure and location in space. What is unit of mass? Unit of mass. So yes, SI unit of mass. SI unit of mass is kilogram. And it is denoted by kg. Yes, it is denoted by kg. Kilogram, that is SI unit of mass. Yes, my mass it is in 57 kg, so it is unit kg, that is appropriate. But if I am taking small object chalk, then is mass of chalk, is it possible in kg? No, it is very, very small. Okay, so its mass is also very small. Then kilogram is an inconvenient unit for measurement of mass. Means we have to derive some smaller units. Okay, to deal with atoms and molecules, we have to derive some another unit. Okay, for atoms and molecules, another unit of mass is defined. Which is called unified atomic mass unit. Okay, and it is denoted by U. Now what is definition of this atomic mass unit? See here, atomic mass unit, that is U, is equal to 1/12 What is definition of this? It is 1 upon 12 of mass of atom of carbon 12 isotope C612 including mass of electrons, so yes, it is definition of atomic mass unit. Okay, what is atomic mass unit? Atomic mass unit is 1 upon 12 of mass of atom of carbon 12 isotope C612 including mass of electron. Now how to find this mass? Okay, what is isotope C612 including mass of electron? How to find? We will see in 12 in chapter number 13, that is nucleus. Clear about this? Right now you have to remember this definition. Okay, what is atomic mass unit? What is atomic mass? Clear about this? And yes, what is conversion? What is relation between atomic mass unit and kilogram? So yes, 1 U is equal to, it is 1.66 into 10 raised to minus 27 kg. 1 U is equal to 1.66 into 10 raised to minus 27 kg. So yes, you have to remember this relation. 1 U is equal to 1.66 into 10 raised to minus 27 kg. Clear about this? So yes, here some objects having unit kg, but if objects are very small, then kilogram is an inconvenient unit for measurement of such quantities. Okay, so yes, we have to take another unit of mass, that is atomic mass unit, which deals with atoms and molecules. Clear about this? So here it is about unit. Now how to take measurement? Measurement of mass. See, measurement of mass. First instrument that you know, okay, that is common balance. First instrument you know, that is common balance. Okay, what is common balance? Yes, you know what is common balance. Okay, suppose yes, it is called common balance, that is used for measurement of mass. Yes, we know that. Okay, in one side you have to put block of known mass, and on another side you have to put things you have to purchase. Okay, so yes, whenever these two plates, they are in balanced condition, we can measure mass. So yes, it is first and one commonly used instrument that is known as common balance. For measurement of mass. Now, how it measures? So it measures by comparing of gravitational force, by comparison with gravitational force. Okay, so yes, it is first instrument that is used. for measurement of mass, and how to take measurement that you know. Okay, already in question solves. Now another is, if we have objects having very large size. Large size means their mass is also greater. Then how to find such masses? So that it is according to Newton's law. From Newton's law of gravitation. Okay, it is used to measure mass of large object. Large object means how? You see, if it is Earth, if it is Moon, okay, distance between them is r, then yes, we know what is Newton's law of gravitational. Okay, what is Newton's law of gravitation? That is F is equal to, it is G, mass of earth, mass of moon divided by r square. With the help of this equation, you can compare mass. You can compare mass. So yes, when you are given objects which are heavy, for heavy objects, for heavy objects, with the help of this law of gravitation, you can measure mass. With the help of this law of gravitation, you can measure mass. Okay. Now, for it is measurement of very large objects. Okay, heavy objects. But how to measure very small particles? Okay, this chalk, its mass, it is in hardly in gram. Yes or no? If I am taking a small piece of chalk, if I am taking particles of chalk, okay, then how to measure mass of such particles? How to measure mass of atoms, molecules? Okay, so for measurement of such very light objects, another method is used, another concept is used, and it is called mass spectrograph. It is called mass spectrograph. Okay. Now, what is mass spectrograph? Mass spectrograph we will see in 12th. Again we will see this topic in 12th. Here I will give you something. When charge particles are projected in electric field or magnetic field, trajectory of charge particle depends on mass. Trajectory means path. Deflection of charge particle depends on mass. Okay, so yes, in mass spectrograph, according to that trajectory, we can compare its mass. Okay, if trajectory or deflection is more or less, so according to that, its mass we can assume it is more or less. Okay, so yes, here in mass spectrograph, trajectory of charge particle in electric field or magnetic field, depends on mass. Now, what is relation between trajectory of charge particle and mass? That we will deduce in 12. That is chapter number 1, electric charge and electric fields. Clear about this? So yes, again see in this 11, yes, this chapter number 1 and chapter number 2, these two chapters are they are introductory chapters. Okay, so yes, you have to accept something. For example, what is Newton's law of gravitation? Right now you have to accept this equation. We will discuss in chapter number 8 in 11. Okay, mass spectrograph. What is this relation? That is trajectory of charge particle in electric field or magnetic field depends on mass. We will obtain this relation. Don't worry about it. We will obtain this relation in 12th. Okay, so yes, after 12th you can easily understand this each and every topic. How to obtain this relation? 1 is equal to 1.66 into 10 raised to minus 27 kg. We will see again in 12th. So yes, right now some definitions you have to remember. Clear about this? Okay, now we will see range of mass. What is range of mass? See, here it is. Range of mass. Yes, range of mass. Again, what is meaning of range? Range means what is mass of the light particle and what is mass of heaviest particle. Okay, so yes, any object is made up of again particles made up of molecules made up of yes, atom is made up of nucleus and electrons revolving around it. So yes, what is lightest particle? Light particle is electron. Okay, light particle is electron, and its mass is in order of 10 raised to minus 30 kg. 10 raised to minus 30 kg. 10 raised to minus 30 kg. So this is very small. Okay. While what is the heaviest, or what is mass of this known universe? Mass of this known universe. Mass of this known universe. Mass of this known universe is around 10 raised to 55 kg. It is nearly 10 raised to 55 kg. Clear about this? So yes, you have to remember this data. You have to remember this data. So see here again, measurement of mass. What is mass? Units of mass. Then how to measure mass? Yes, for some objects that we use in daily life, we measure mass with the help of common balance, with the help of spring balance. Okay. Yes, objects which are heavy in size. Okay, that mass we have to measure with the help of Newton's law of gravitation. And for light objects, light objects, we have to use mass spectrograph. And it is range of mass. It is about range of mass. Clear about this? So yes, with this measurement of mass is over. Now next quantity is measurement of time. Measurement of time. Okay, time. How to measure time? Yes, measurement of time is based on clock. Yes, we use clock for measure. Clock is used for measurement of time. Okay, now clock is based on which phenomena? So yes, this clock is based on which phenomena? Right now, to measurement of time, we use atomic standard of time. We use atomic standard of time. Which is based on periodic vibrations, in cesium atom. And such clock is called known as cesium clock or atomic clock. Okay, so yes, clock is used for measurement of time. We use atomic standard of time, which is based on periodic vibrations in cesium atom, known as cesium atom or cesium clock or atomic clock. Now, cesium, it is one material, it is one element. Okay, in 12th, you will study. Okay, when electron makes transition from higher energy level to lower energy level, it will emit some electromagnetic waves. Again, when electron makes transition from higher energy level to lower energy level, it will emit some electromagnetic waves. So what is second? Yes, second is time, which is needed for 9,192,631,770 vibrations. Okay, vibrations of radiation which is produced due to transition between two levels, layers. So yes, this thing you have to remember. What is second? Second is time needed for 1 second. 1 second is time needed for 9,192,631,770 631 777 770 vibrations of radiation, okay. When electron makes transition between two hyperlevels, between two energy levels in cesium, Yes, again, right now you have to remember this data, you have to remember this definition. Okay, 1 second is time needed for 19192631770 vibrations of radiation when electron makes transition between two energy levels in cesium. We will study about this in detail in 12. Okay, because right now I have to explain you, okay, what is energy levels of electron, what is energy difference, what is Bohr's postulate. Okay, so yes, I have to explain you each and everything. So yes, about this we will see in detail, in 12. Clear about this? So yes, right now you have to remember only this topic, okay, how to measure time. Clear about this? And yes, for each and every SI unit, that is kg or atomic mass unit or this second, okay, the replica is available. At each and every place in this earth, on this earth. Okay, so yes, for common units, for common internationally accepted units, replica is used. Clear about this? So yes, it is all about measurement of mass and measurement of time. Yes, we have completed measurement of length, measurement of mass and measurement of time. Yes, here we will see only measurement of these three quantities. Okay, next quantities, they are derived quantities. So yes, if you know how to measure mass, how to measure time and how to measure length, you can also find, or you can also measure the quantities which are based on this fundamental quantities. Clear about this? Okay, now after measurement of such quantities, we have to understand two terms, accuracy and precision. Now what is accuracy and precision? What is difference between them? What is difference between accuracy and precision? That we will see here. Okay, accuracy means what? See, accuracy, first of all we will see definition. Accuracy means what? Accuracy means how close measured value is to true value. Okay, how close measured value is to true value. How close? Okay, we will see with the example. Right now you have to remember definition. Okay, it is measure. Accuracy means how close. It is measure of how close measured value is to true value. But what about precision? Precision tells us up to which resolution quantity is measured. Up to which resolution it is measured. Okay, now what is meaning of these two quantities? See, first of all, for any instrument, it has some least count. It has some least count. For example, for scale, least count is 1 mm. Yes or no? It is 1 mm. 1 mm means it is 0.1 centimeter. So reading with the help of scale, they are like this. For example, length is equal to, it is 3.5 centimeter. It is 3.5 centimeter. Why? With the help of vernier calipers. Its least count is, it is 0.01 centimeter. Yes, it is 0.01 centimeter. So length measured with the help of vernier calipers. How to write? It is nearly 3.67 centimeter. I have assumed these values. Okay. And if I use screw gauge, then its least count is 0.001 centimeter. Then if I am taking reading with the help of screw gauge, then it may be like this. It is nearly 875 centimeter. Clear about this? So see, this measurement of any quantity, it depends on its least count. It depends on its least count. Clear about this? Yes. Here, if I have this length and its true length is 3.4 centimeter. Its true length is 3.4 centimeter. Now understand, out of these three readings taken by three different instruments, which one is more accurate and which one is more precise? Okay, so you can easily understand difference between accuracy and precision. Again, what is accuracy? Accuracy means it is measure of how close measured value is to true value. It is true value 3.4 centimeter. Measured value and measured value. First measured value is 3.5, then 3.67, then 3.875. Now which one is close? To true value? Obviously 3.5 centimeter. So it is called accurate reading. Clear about this? It is called accurate reading. Okay. Now which one is more precise? So see, precision tells us up to which resolution it is measured. Yes, least count of scale is 0.1 centimeter. Least count of vernier calipers is 0.01 centimeter. Least count of screw gauge is 0.001 centimeter. So resolution of screw gauge is more than resolution of vernier calipers, and it is more than resolution of scale. Clear about this? So yes, here resolution in this reading is more. Okay, in this reading resolution is more, means it is more precise. Clear about this? So yes, it is difference between accuracy and precision. Accuracy means the measured value which is close to true value. Clear about this? Okay, and what about precision? Precision tells us up to which limit measurement is taken. Okay, here it is 3.5, means after decimal point we are certain about only one digit. In this case, we are certain about 2 digits. In this case, we are certain about 3 digits. So obviously, this reading have higher resolution, and as it has higher resolution, it is more precise. So see, it is not necessary that the measurement which is accurate, it must be precise. No, here this reading is accurate, but it is not precise. This one is precise, but it is not accurate. So yes, the reading which is accurate, it is not necessarily precise. Clear about this? So yes, it is difference between accuracy and precision. Clear about this? Okay, now we will see one extra topic. We will see one extra topic. See what is extra topic. Now see what is extra topic. This extra topic is about multiples and submultiples of SI unit. Some multiples and submultiples you know. For example, yes, you know what is centi, what is milli, what is nano, what is kilo. Okay, so yes, you have to remember these multiples and submultiples of SI unit. 10 raised to minus 1, deci, indicated by small d. 10 raised to minus 2, centi, indicated by small c. 10 raised to minus 3, milli, small m. 10 raised to minus 6, micro, mu. 10 raised to minus 9, nano, small n. 10 raised to minus 12, pico, small p. 10 raised to minus 15, femto, small f. 10 raised to minus 18, atto, small p. Here, positive powers, 10, deca, da. 10 raised to 2, hecto, h. 10 raised to 3, yes you know, kilo, that is k. 10 raised to 6, mega, capital M. 10 raised to 9, giga, capital G. 10 raised to 12, tera, capital T. 10 raised to 15, peta, capital P. 10 raised to 18, exa, that is capital E. So yes, you have to remember this each and every topic, each and every multiple and submultiple. Clear about this? Clear about this? Because if I have one example like this, okay, L is equal to, it is 3.9 into 10 raised to 9 meter, into 10 raised to 9 meter. Then I can also write this length as 3.9. 10 raised to 9 means, 10 raised to 9 means it is giga, so I can write it is giga meter. Clear about this? Okay, so yes, it is use of multiples and submultiples. Use of multiples and submultiples that you have to remember. Clear about this? Okay.